day. In today's video, we'll see how we can use the M8190A to generate some waveforms and apply the sequencer function that we have with the AWG. We have this connected to a HD3 scope so that we can check out the different waveforms that we'll be sending using the AWG. So what I have on the screen right here is the physical connections. Let's just slowly run through them. So on the left, it's the M8190A. Just bear in mind this requires a 15 amp power, and you will have to turn on the switch at the rear of the AWG. Then the power button is on the top left corner, so it's blue once it's turned on. And in this example today, we will use the direct out of channel 1 connected to channel 1 of the HD3 scope, as well as direct out of channel 2 to channel 2 of the HD3 scope. Now let's just quickly look at the front panel just so you have a better idea of the ports that are available. So in my previous photo, you would have seen the display port that's connected to the monitor, so that you can see the whole front panel of the AWG. I also have this connected via LAN, so I could remote into it. So these are the two direct out ports. I have here only channel 1 with the cable. I have this without the cables, just so you could see the other ports that are available on the M8190A. Alright, so now that we're clear with the physical connections, let's have a look at the front panel. Okay, so now let's see how we can run the front panel. We'll look into the M8190. Let's click on it. So I have this connected remotely, so that it's just a little bit clearer. And I do have HD3 scope on the right of the screen here. So let's connect. And this would be the front panel. We can see. So let's just very quickly run through some of the tabs that we have here. If you happen to use the internal clock or the reference clock, you will have the access to it on the first tab. So in this first example, I'm only going to use channel 1, but of course you get to choose between 14 bits or 12 bits. In the different formats, you can of course adjust the amplitudes and offsets here. So by default, this would be disconnected. I want this to go out of the direct out of channel 1, and I will keep it as such. Then you also have the auxiliary ports if you need to play with triggering. This is an important tab, and we will look into it in a little more detail in just a bit. So this is where you would define the waveforms that you'll like to generate. We will come back to this in a short bit. Then there's multi-tone, complex modulation. You can also import waveforms, for example, if you're using IQ tools. And then we have the sequence table, and that's where we will have a look at quick sequencing. And lastly, there's the status control tab. This is where, if you will, you'll turn on and off the waveforms. Alright, so let's have a quick look now. I'm at channel 1 only. I do want to play around with a few waveforms, so we will just start off with the segment number 1. I'll just change this to a 150 megahertz signal. So sample rate, because I would like to look into the sequencing, I will just keep the sample rates the same across all of them. So that's 5 to 8 samples. I'm happy with that. So we can just go ahead and send to instrument. So at the bottom here, you should see that the waveform transfer is completed. Now I can then proceed to generate another segment number. Let's do 200 megahertz. So as you can see, I would have changed it. I am keeping the sample rates the same so that when we look at the scope later on, it just makes sense. Okay, so transfer is completed. Let's continue with segment 3. Let's do 320 megahertz. So now I've done 3 segments. So we can now have a look at what we have here. Let's go to arbitrary and continuous. So I'll just play the different segments, and we should see that waveform on the scope on channel 1. So this is segment 1, and if we remember, that would be 150 megahertz. So I do have the measurements added, which you can do through this. So I have checked frequency and period. And as you can see, that is 150, which is great. So just a little warning here that channel 2 is not enabled, and that's correct. Now let me stop that. Let's go to segment 2. As you can see, that's 200 megahertz as we had wanted. If I were to do that, just to check on the periods, that should be right, which is around 5 nanoseconds for a 200 megahertz signal. But of course, your measurements here would show that. Now let's go to segment 3, and you should see 320. It's all looking in order. Let's go back to the AWG on the left, and let's create a sequence table. So instead of just having all of them as segment 1, I'll do segment 1, put an idle state there, make this segment 3. Let's just switch around a little bit. I might want to increase this just so we could have a look at the different segments. Idle state, and then we can move to segment 2. I'll just put a wider loop here, and then let's just put this to idle. It may complain if the sample size are not good enough, but let's try that. I did not get an error, so that's good. So it's a sequence data is set to instrument. So if we have a look here, segment 1 is 150 megahertz, and then I'm going to 320 megahertz, and then I'm switching back to 200 megahertz. So now if I go to the status control tab again, instead of arbitrary, I'm going to do a sequence continuous. So you need to ensure it's the right sequence ID. So that's 0. If we go back here, this is 0. And let's hit run. Does complain. Let's just have a look at what it says. Aha. So there, I have missed something. If we hit back to sequence table, I need to say that this is a new sequence. So let's clear that error. Set to instrument again. Now if we run, you can now see it switching between different frequencies. 150 megahertz might be a little short there because I only have it for 5 loops. Here's an example of how you can run the sequencer. So now we'll just repeat this with channel 2 since I do have channel 2 turned on. So I will just clear this list and let's stop the display. Now let's head back to standard waveform. I have already generated some waveforms into channel 1, so now I will continue with channel 2. Say for example, I'll continue on that, and let's start with 400 megahertz segment 1. Segment 2, let's do 500. Segment 3, let's do 520 megahertz. Alright, so we've done all waveform transfers completed. Now let's go back to the sequence table and add a few more rows here. Okay, let's have a look. So I did have channel, so I'll not add any more data, but if you remember the different segments 1, 2, and 3 are different for channel 1 and channel 2. So now if I were to send the sequence to both channels, we should see then the 400 to 520 megahertz signal displayed on channel 2. So the sequence data has been sent to the instrument. Let's go to status control. Instead of arbitrary, I will put this as sequence as well. And now Let's see if this would run. So it does complain that I do have a playtime that's too short. Let me just fix that up and I'll be right back. So to do that, I'm just back at the sequence table. I'll just increase the segment loop so that there's enough samples. Now, because I do want to have the second channel displayed as well, we need to make sure we have this connected at the output tab. Now, if I hit back to status control and run, we can now see the different signals. Let's have a look for channel 2. I like to put some measurements into this as well. Yep, let's do that. Let's add frequency and period. So you can now see it, all 6 segments are being displayed, and that's how you can run a sequence using the M8190A AWG. Thanks for watching.